Welcome to the 10.4 podcast on centripetal and centrifugal forces. And we're going to be talking about the centrifugal force, which is often called a fictitious force. So the centrifugal force effect is attributed not to any real force, but to inertia, the tendency of a moving body to follow a straight line path. So let's look at this. We can sometimes when you're moving in a circle, you'll feel what appears to be an outward force. And if you look at these people on the on this spinning carnival ride, you can see they're all appears to be pushed to the outside. So this apparent outward force that you get from rotating or revolving is called a centrifugal force. And centrifugal means center fleeing or away from the center. Now, remember, when a string breaks, the whirling can moves in a straight line on a tangent, not outward from the center of its circular path. So often, what we would say is that a centrifugal force pulls on the outwardly on the can, but that's not true. If the string breaks, the can's going to go off in a tangent straight line path, and the reason why is because no force acts on it at all. At that point, when the string breaks, there's nothing holding, pushing, pulling, or anything on the can, so it just keeps on moving in the direction it's going in a straight line. So, and the only force that acts on it is the string to the can, so the outward force is on the string, not on the can. So the only force that's on a can actually would be gravity, other than this from the force in the string, and that's directed toward the center of the circular motion. This is the centripetal force, and we talked about this earlier. So if you look at the can here, and let's imagine there's a ladybug in the can. As the can goes around, there's a centripetal force pulling the can towards the center of the circle, and as a result, the can is also pulling towards the center on the ladybug. So the can presses against the ladybug's feet, and it holds the ladybug in that circular path. And as a result of that, the ladybug pushes against the floor of the can. So the only force acting on the ladybug is the force of the can on its feet. From our frame of reference, we see that there's no centrifugal force on the ladybug. What causes the centrifugal force effect? The centrifugal force effect is attributed not to any real force, but to inertia, the tendency of a moving body to follow a straight line path.